Hello and welcome to the Food Chemistry Film Festival. Today I'm going to be talking to you about mycotoxins, and specifically the ones found in peanuts and wine. Well, what are mycotoxins? Mycotoxins are any toxic chemicals produced by a fungus, and we're going to explore where it all comes from and why it is so bad for us. Mycotoxins really came to the scene in the 1960s, when the discovery of aflatoxins was made in Brazilian peanuts. There are 14 different types of aflatoxins, produced by a fungus called Aspergillus, which has a few hundred subspecies. This is the general structure of aflatoxins. The worst case scenario is acute liver failure, which is only treated with a transplant. However, chronic exposure typically shows no symptoms and can result in the eventual onset of hepatocellular carcinoma, or liver cancer. This is the better of the two options, as there are more treatment options available. Aflatoxins grow best in tropical environments. The high humidity in the air is ideal for the fungus to grow and spread. There are a number of ways of effectively controlling aflatoxin outbreak in crops, including nuts and wine. The first method is ammoniation. This involves passing 1% concentration of ammonia gas through the crops in a humid environment in a high temperature and pressure. This opens up the ring structure as seen here. Ammoniation in peanuts reduced the presence of aflatoxin B1 from 121 micrograms per kilogram of crop to undetectable levels. This works by opening up the lactone ring to form the hydroxyamide. However, this reaction is reversible, and if the pressure and temperature are not high enough, B1 will return. Whilst this method is effective in nut crops used for feeding livestock, this method is not perfect and should be used with other treatment methods. The second method explored is ozonation. This method is less effective and is usually reserved for nut crops that are usually used exclusively for animal feed. The reaction pathway of ozone with mycotoxin depends on the chemical structure of the mycotoxin. The mechanism of reaction between ozone and the alkene double bond to form ozonides has been proposed, where the ozone molecule undergoes 1,3-dipolar cycloaddition with a double bond forming 1,2,4-trioxylane ozonides from alkenes with aldehyde or ketone oxides formed as intermediates. Ozonides undergo oxidative disintegration into carbonyl compounds, carboxylic acids, and ketones. 6 aflatoxin B1 ozonation degradation products have been identified. The existence of double bonds between the C8 and C9 of aflatoxin B1 explains greater susceptibility to ozonation as compared to aflatoxins B2, where this double bond is absent. In wine, the addition of sodium bisulfate hinders the growth of organisms including Aspergillus. An added bonus of this food additive is that it can undergo addition across the double bonds found. The treatment of future mycotoxin is likely to lie in utilizing hydroponic lamps during the growth stage. UV light has been found to be able to modify the structure of aflatoxins, making them safer for consumption. If you enjoy this video, please like, rate and subscribe to see all our future videos.